We'll start with day 2 of the vectors and navigation. Now, before we start, I want to go over a couple of things. The first thing is that how do we tell direction? We know how to tell north, east, south, west, so I want to make sure that you know this is north, and north is 0 degree. Okay, and east is 90 degrees. Okay, so when we do bearings, okay, make sure that you know the way we label our degrees, the angle, it's different. Like before the bearing stuff, like in the past, we say the right hand side, the beginning of first quadrant is 0, and then up it's 90, 180, right? But with bearing, it's slightly different. So make sure you change the frame of reference, okay, when we do these problems. Now, the 2 problems here today, they're going to give you 2 different flavors. So let's read the first question. An airplane is traveling in the direction of 200 degrees with an airspeed of 250 miles per hour. There is a 35 miles per hour wind with a direction 285 degrees. Find the plane's ground speed and course. Now, we'll draw a diagram, okay? But before we draw a diagram, I want to make sure that you understand a couple words here. Airspeed means the speed of the airplane in the air by itself, right? So if the airplane is traveling in some still air, like no wind at all, this is 250 miles per hour. That's the airspeed. But, you know, there's always going to be some wind in the air. And with the wind blowing, then the actual speed, it's going to be different. So when we say the ground speed, that is the actual speed of traveling. That's the actual speed, okay? And that's also the resultant, okay? That is the combination of the airplane's original speed and the wind speed together, okay? So a simple idea, okay? A simple idea is that if a plane that goes 100 miles per hour and then the wind is blowing at 10 miles per hour, so the actual speed is 110 miles per hour. That's a ground speed. Okay, so airspeed of 100 with the wind 10 miles per hour. So if they're aligned in the same direction, well, then they will add up together. So the ground speed would be 110 miles per hour. So now we're going to calculate something like similar, except that the directions will be different. And the directions are not like simple horizontal or vertical. So we have airplane. Now, by the way, I think the worst starting point that a student could have is that they draw a tiny diagram. That's no advantage to draw a tiny diagram. Make sure your diagram is big enough. We got space here, so utilize the space wisely. So here, draw a cross, and then that's the starting point, and it's going to travel in a direction of 200. Okay, direction of 200, so somewhere like this, at a speed of 250 miles per hour. All right, so you can see I draw a long arrow. Go ahead, draw a long arrow. And this is 200 degrees. Now, it's also recommended that when you draw these angles, always be very sensitive to the information that you could tell without being prompted. Like if you draw this 200-degree angle, what other angle can you tell? The other one is 160, yes. And also, what's this one here? Yeah, this one right here, that is 20 degrees. Okay, so so you may want to label this. This is 20 degrees as well. Okay, you know, you can write it down, or just mentally you tell yourself that, hey, I know this angle. Just be ready. And then the wind direction. Okay, the wind direction, it's going to be affecting the airplane. It's 35 miles per hour at a direction of 285. Okay, now, so I am going to do this. I'm going to use a blue color. So it's going to affect the plane. So 285 degrees will be somewhere like this. And 35 would make it a short arrow compared to the other one. So this whole thing is 285 degrees. And this is 35 miles per hour. Right? So the plane is traveling southwest, but the wind is blowing at a northwest direction. And again, we want to find out the ground speed. That means we want to find out the resultant. So how do we find out the resultant? Well, we have two vectors. If I want to find the resultant of two vectors, what must we do? What must we do? Remember, if you want to find the resultant, the vectors must be connected head to tail. And at the very beginning, it was not. Okay, so remember, you can write this down on the side if in case spring break kind of brainwashed you. Okay, resultant vector means the vectors must be connected from head to tail. Vector must be connected from head to tail. So that's why you have to recreate this vector here. Okay, and the resultant vector will be from the beginning to the end. And we say, hey, could you find out the length of this side right here? And also, could you find out the bearing, the angle right here? Okay. So that's why I ask you all to draw a big enough diagram. If you draw a tiny diagram, you're going to cramp all these things together at a tiny little space, and it does you no good in solving this problem. All right, now, so how can we find the length here? Okay, so the first thing I'm going to ask you, can you find out this angle? Okay, with all the info given, can you figure out the puzzle? What is this angle? Highlight it here. Say again? 195? Yeah. 75, it's part of it. Now, so if from north all the way to the blue line is 285, well, if you subtract from 360, well, this part is 75 degrees, right? So this part right here between the blue line and the north, that is 75 because 360 minus 285 is 75. But what about this tiny little slice of the angle? What about here? 20. Okay, this is 20 because of the alternate interior angle. Okay, so this line and this line, they are parallel, right? They're both north-south. So therefore, this angle is 20 degrees. So all together, this is 95 degrees. Okay. So just be ready to use those parallel lines to make your conclusions. Okay. So this is 20, that's 20. So be very sensitive with all these little small angles. So you have two sides given, one angle given, and you want to find your third side. So the only thing you can use to find out this would be the law of cosine. So I say x squared is equal to, by the way, get a calculator if you need one. So 250 squared plus 35 squared minus 2 times 250 times 35 cosine of 95 degrees. All right, so go ahead, give you a minute to find out what x is. Okay, so if you put everything into your calculator correctly, you should get 255.441 miles per hour. Okay, so make sure you type everything correctly. I've got a student typing in 55 instead of 35. So those things you want to make sure you input it correctly. Okay, so we got the speed, we got the ground speed. Okay, so with the influence of the wind, so the actual airplane speed that's observed from the ground, the actual traveling speed is 255.441 miles per hour. And now we say, all right, now we got the speed. What about the direction? What about the direction? And the key thing, I would say the key thing right here is, do you know that you are now capable of finding all the details of the triangle here? Like with all three sides and this angle, you can find out everything. You can solve the triangle. You can find out the remaining angles if you need to. So, well, if you look at this, we want to find out this purple line's direction. Well, we know the black line is going to be 200 degrees. So, and we are changing this direction for just a little bit here. So, if that's the case, can we find out this angle? Can you find out this tiny angle right here with the information given? Can you find out this purple angle? And let's call this angle A. Can you find out angle A? Or theta, if you want. Yeah. Or theta prime, whatever. Okay, so we'll say, well, if you know, if you want to know the angle, we can simply use law of sine. So sine A over 35 miles per hour, and then sine of 95 degrees over 255.441 miles per hour. So you can now go ahead and find out what sine A is, and then you will get what A is equal to. Okay, so let's go ahead and find out what they are. So you should be able to find out that sine A, it is 0.13647. and do the inverse of this, your angle A should be 7.845 degrees. Okay, 7.845 degrees. Now that's just the angle A, but the actual course is what? So if you know angle A is 7.845, so what is the actual course, actual direction? Say again? 207. So basically you tag on 200 degrees on the 7.845 degrees, so 207.845 degrees. Okay, yes? 200 is the one with the original original airplane's direction. So since it's being nudged a little bit more to the west side, so we just find out that little angle difference, and then we just tag on the angle difference to the 200. That's it.